Hi folks, welcome to another episode of NYC CNC. I have got Drew here from Mitutoyo.
Hi guys.
Mitutoyo reached out and said, we want to film with you, and I thought, that's awesome. And I said, you know what? I want to understand basic job shop metrology. Metrology, fancy word for measuring stuff. We've spent a day here learning some really cool high-end stuff, but what I want to understand is the tools that I've got, the gauge blocks, the micrometers, the calipers, how do I use those? What am I doing right? What do I need to do better or be conscious of?
You know, John, a good place to start is with micrometers. Everybody has micrometers in the shop. You have several here. We've got a couple different kinds with us. One that has a friction thimble on it,
Yep.
one that has a ratchet thimble.
Yep.
And this is going to be good for repeatability. You know, one of the best things as far as getting repeatable measurements is to use constant force. And this is going to allow us to have the constant force for your measurements. This is especially good if you're using the tool one-handed, right? Because then as you reach your limit, you're going to have a clutch mechanism.
Yeah, the click out.
Ratchet, exactly, to let you know it's there.
Yep.
Also, the ratchet tool is fantastic to use if you're using the micrometer to stand like we have here.
I've got some older manual micrometers or analog, and they don't have the ratchet, and I don't trust them. I don't even use them because I want that clutch out feel.
Exactly.
Cool.
John, another great thing with micrometers, especially if you're measuring larger diameters, is to use what we call the pivot and swing method, which is where we open our tool, get it close to the diameter size that we're going to be measuring, and we'll typically anchor the micrometer with one side. I like to use the anvil side here.
Yep.
But then what we'll do is I'll get the tool close and we'll kind of pivot and spin to help me find the apex of the diameter that we're measuring as well.
And I can do that this way, or I can do it this way along the part?
That's correct.
Okay.
I prefer to do it the other way just because you can see the number, but whatever works best for you,
right.
as far as that goes, but absolutely.
This totally reminds me, again, so much of what I learned on YouTube about machining was from YouTube, and two guys, Adam Booth and Keith Fender, who are always doing that with when they sweep a big part in, they're kind of rotating it back and forth, finding that high spot.
Absolutely.
I recognize these.
You recognize
these? Are my daily my daily drivers.
The bread and butter, huh?
Yeah, right.
So what we have here is the caliper, guys, and a couple things to check on that is to always be using constant force. That's going to be one of your biggest factors, is to make sure you're not exerting too much force as you're doing a measurement. Try to keep it nice and consistent. There's three basic areas on the caliper here. We have the edge of the jaws. We kind of have this middle machined area, and then we have the inside groove area. We want to try to stay away from using the edge of the caliper as we're doing the measurement. Try to stay in this little machined area. Try to stay a little bit more towards the top of that. And that's going to give you better accuracy, consistency, repeatability on that as well.
They were explaining at lunch, there's a thing called Abbe's Law. Who knew? Where when the measuring device, like the digital scale or linear scale, isn't in line with basically the further out you go, the more error you possibly introduce, which is crazy to think that there could be deflection out here at the tip, but that's a lot of distance and it gets thinner, and I guess it makes sense.
Absolutely. Also, with any measuring tools, a good rule of thumb is just to go ahead and make sure that the jaws, your contact points, are clean before you start measuring. You know, just kind of try to just make sure there's no debris on it. Above and beyond that, you can get some lint-free wipes, maybe a little rubbing alcohol, clean those contacts up. Also, if you're not sure about your measurements, a good rule of thumb is to put the jaws together and hold it up to the light, and make sure that right here we're not getting any light coming through.
So that's like, again, these are my daily drivers. They're all around the shop. That's the first thing I do in the mornings. I open them up, I do the finger swipe. So you're okay with that in terms of like skin oil or whatever. The light thing I've not done. That's a great tip. Do I need to buy, so no special chemicals needed?
No special chemicals needed on that.
Cool.
And obviously, always zero out the tool before using.
And you don't care whether I use my thumb on the plastic or on the roller here?
Correct.
So constant force is, in this case, I don't have the benefit of a mechanical clutch. It's really up to you.
That's correct. You're going to have to develop the feel for that.
Right. Cool. So one of the things I know I need to do, and it's actually the reason we picked up this linear height gauge, I need like one really good measuring tool that I can use to confirm or calibrate to the extent I need to as a job shop. The other measuring tools I use, I really also need to pick up one good micrometer. I'm kind of guilty of not having at least one good mic, and we were talking about that. And when you do get a mic, whether it's a high-end or low-end one, making sure it's set correctly.
Absolutely. Obviously, on a 0 to 1 inch mic, that's very easy. Move the spindle all the way into the anvil, you hit 0 and you go.
Right.
What about on a larger mic? Obviously, the 2 points are not going to contact each other. So that's where most mics will come with a reference artifact such as this. You can also use gauge blocks. Always remember when you use an artifact like this, not to use the nominal amount that's stamped onto it. Use the actual certified value.
Certified value, right,
Absolutely.
Which timeout, that's crazy. Like when you have gauge blocks or you have a standard that has a number on it, be careful. You may actually not want to pay attention to the number that's lasered on it. You might actually want to get the paper sheet that's with it that has the actual calibration on it.
Absolutely, absolutely.
Yeah, damn it, that's deceiving.
Yes, sir. So again, just coming back over here, I'll set up my artifact here. Have it set. Make sure I don't have it at a little bit of an angle.
Right.
For a moment ago. And then we can use the buttons on the front of the micrometer to actually go in and preset the tool to match whatever the actual value of the artifact is that we're measuring.
Got it. Yeah, the clutch there. I guess I could use the light trick here as well, because this is so important to keep it in line, right?
In this scenario, you should be able to because of the flatness of each of the contact surfaces.
Right.
Yeah.
It's funny, we talk about it in our chip break series. It's why we have our shop so organized. You make better parts when you're organized. And I say that because when the right tool is right there, you're more willing to use it, because at the end of the day, we're all kind of lazy. So the thing about this, awesome about this, watch this. 1 turn, 2 turns, 3 turns. It's like a rapid pitch lead screw. So cool, and it is just as accurate.
Exactly. This is the Quantum mic series, and so this, as you mentioned, is 4 times faster than a regular mic. But in the past, any micrometers that you had that had a faster speed, you sacrifice something for it, usually the accuracy.
Got it.
So in this scenario, we're maintaining the accuracy about 4 times faster on the travel.
I see like no drawback other than I assume it's more expensive.
You know, you'd be surprised. It's only about $20 more than
that's a no-brainer.
The standard version.
That's awesome. Anybody have a Quantum mic? Because I think I'm going to buy I guess this is the 0-1 to start, because that's awesome. I hate when I have to go from a 3/8 inch to a 1 inch, and I usually will end up getting 2 mics because I hate moving between the two.
Understand.
Awesome.
No more having to go up and down the sleeve.
I like that trick.
Yeah.
That's a cool trick. Raise your hand if you heard of Cosign Air. Classic example. I'd heard of it. I always ignore it because it sounds complicated. Basically, and by the way, click a card here. We actually played around with this and what it actually means, but when you have your indicator presented to the reference plane or the measuring plane at an angle, it's no good, meaning the absolute measurement is not accurate. The relative measurement would be fine. So what does that mean? What do we need to be conscious of?
Well, one thing, we always want to try to make sure that we are set at the correct angle for the measurement.
So just bend the stylus.
Exactly.
Right.
Bend the tip, make sure that we're parallel to the surface that we're measuring. Now, it's not the end of the world if you're off. For the way you had this holding a moment ago, if you have to use your test indicator in this orientation, it's not the end of the world. You just need to be aware of what the cosign will do to your measurements.
Yeah, right. The fun thing about this video is I get to learn stuff from them, and then I get to sound smart. Like, for instance, fun fact, if your indicator doesn't exactly repeat in its free state, that's not actually a bad sign. Mike, one of the AEs, was explaining that when you have it come to rest, it's just resting on some sort of a dead stop, and that dead stop isn't really meant to be a precision indicator. So both with test indicators and with regular dial indicators, what you care about is the repeatability when they're actually preloaded.
That's correct. Yeah, the resting area is not always within the measurement range.
Got it. Is it okay to, like, even just free state, can I over travel? Like if I do this, is that hard on them? Pushing it?
Just going through the full range of motion, no, but repeatable, trying to exceed that range of motion, you know, with every tool you can kind of feel where there's a natural stop on it. And especially on dial indicators, you don't want to try to constantly move it faster than the physical limit on that, because that can cause damage to the indicator.
Right, but you know, the general rule when I want to see if an indicator is good to use in the shop, or if I'm looking to pick one up somewhere, the first thing I do is I kind of feel
check the range, make sure it's not sticking along that nature. Absolutely.
Awesome.
One of the other important factors about the test indicator is how you present the part for the measurement.
Okay.
So for example, we have our test indicator set up here. I have a round cylindrical part here. I'm going to move the part away from the test indicator to bring it into range of motion.
Okay.
I'm also going to spin it away from the part as well.
Got it.
Why is that important? Well, this is a nice cylinder. There's no notches or anything in it.
Yeah.
But what if there were a keyway cut in it?
Oh.
And as I'm rotating it this way, that keyway comes around. It could get caught in to the test indicator. The other thing you're going to notice about the way we're set up is we're always staying on the ball itself.
Yeah, right.
Of the stylus, not on the shank. So we always want to make sure that we're contacting the ball itself and not the shank.
It's funny because you really have to pay attention, because you want to be on that ball, but you also want to keep it as close to parallel to the part as you can, which means you're going to be closer. You just have to be on your A game, and I've noticed it too. I love the Noga bases with the adjustable part here, because it's easier to use these tense indicators and get your part dialed in. But if you bump it going the wrong way, you got to start over, because now you can't. I don't trust the reading anymore.
Absolutely. Speaking of trusting the reading, have you ever went to use a test indicator and maybe you feel like the movement is maybe half or maybe even double what it should be. A reason for that could be these styli, the probe that's on the test indicator itself, those are interchangeable.
Okay.
Not all manufacturers use the same length, but each test indicator is set for a certain length of stylus. So what that means then is, let's say you have a drawer full of styli and you just go to swap or interchange them out. If you get a stylus that's twice as long as you're measuring now because of the pivot factor, it will in effect cut your numbers in half. So you'll be expecting to see much more travel on your dial than what you're seeing.
I'm thinking about the indicators that I've bought or been given by friends or just used, and I have no idea if, I guess I would just have to check them.
Absolutely. And some indicators, such as this guy right here, or even the one you're holding, actually have a little indicator on the front that spells out what the stylus length should be.
It's funny, this goes back to the Richard King scraping class that I just took, which was awesome because it kind of cut down to the foundation of not only just metrology, but of doing stuff, which is assume nothing. Check everything. That expensive brand name indicator that is really responsive, someone in all good intentions could have swapped out the stylus for bigger or smaller ball, and now all of a sudden it's totally giving you garbage because that's funny.
Your quality is only as good as your method of checking it.
And it was fun too. Yesterday, again, in that video where we were playing with Cosign Air, we tried to do the math ahead of time to figure out, are we going to get the answer we expect? So it's actually not hard to take a piece of feeler gauge and see if it's reading correctly.
Absolutely.
So gauge blocks are probably the tool that I've started using the most on a regular basis over like the past year, and they are so cool, but there's also some interesting things you shouldn't do with them. If they do not ring together, then you've got a problem. And if they don't ring together, they also aren't going to be accurately representing what you're trying to do, which is in this case, putting a 9 and a 950 together to give you 1.85 inches. So you were showing me this. You want to, actually you do, you were better at it.
Absolutely. So gauge blocks are the foundation for a lot of our measurements. We mentioned earlier about calibrating or setting your micrometer, and a lot of times folks will do that off gauge blocks. You always want to take care of your gauge blocks. Make sure that the surfaces that you're measuring are clean. If you're concerned about the surfaces themselves, again, like we talked about with the caliper, just use a lint-free wipe and some rubbing alcohol. That's fine to take care of it. Nothing special off the shelf on that. Excuse me. These are ceramic, so these will wear a lot less. They'll have a lot less wear than the steel itself. But you know what's nice about that is ceramic doesn't just ring to ceramic, it can also ring the ceramic to a steel block as well.
These ceramics are really cool. Like this is total metrology candy. They don't wear as much. They don't corrode. They're really out of my price range, and I was mentioning that, and they said, but you don't have to buy the full set. If you use a couple sizes a lot, buy those individual ceramics.
Yeah, buy the steel set, then you can buy the ceramic to interchange because again, they ring together. That's one of the nice things about it. So to get to the long-winded answer to your question, let me go ahead, and I typically like to start with my gauge blocks perpendicular to each other like this. So I apply them together. I'm not pushing very hard, but I am applying a little bit of force. So I'm going to kind of start to the edge, so almost in an all L shape, more or less. Pull back, and I'm pushing down just a little bit, and I'm barely pushing, but I can already feel the air moving out, the resistance.
So here's what's crazy. We were playing around with these yesterday, and there's different amounts of ringing, like seriously, and I don't know how to explain ringing, and if somebody post in the comments below if you think you can. It seems to be a little bit of a mystery. It's for sure legitimate because look, this is a very expensive 3-inch ceramic gauge block, and look, and watch, see if you can like watch as try that again. So let me try it again.
Absolutely.
So here, pushing together. You feel it. You feel it pick up.
As if there's an adhesive there that there's not.
It increases the drag as I make more surface area contact.
It's a natural phenomenon. Your surface finish of your blocks have to be just right, and then as those are moving together and all air is being removed, it's like magic. But never store them rung together, right?
Never store them rung together. Got it.
Make sure that as you're storing your gauge blocks, go ahead and break those back apart.
Mitutoyo will not be coming back if I drop this right now. So here, watch this. You hear it pop apart. That's cool. So 2 things that I learned with the gauge blocks. Number 1, go to the certification that comes with the gauge blocks. Don't trust the value on them. And if they aren't rung together, you cannot believe the stack height you're getting.
Absolutely. Especially, let's say you're checking a height gauge, for example. Well, if you're using individual blocks and you're going off of the value that's stamped on it and not the actual certified value, you might be okay. But as you start ringing those blocks together and then you're stacking up your tolerances, you're going to start to notice a difference on that.
Got
so
it.
Always use the certified value. And it's not as expensive as you would think to send out gauge blocks that have it calibrated.
Oh, yeah.
It's going to depend on where you send it.
Okay.
But somewhere in the neighborhood of about $5 a block.
Okay, so I can send this block to Mitutoyo in Illinois, and they will send me back for $5 plus whatever shipping. It's certification of what it is.
Yes, sir.
That's awesome. Something I've also started doing is, because I'm a bootstrap entrepreneur and I'm a lower end job shop guy, I've got a set of gauge blocks out in the shop, and then I keep a set kind of in the office, which is my metrology set that doesn't get the wear and tear of fixtures and daily use.
So also note too, and on that note, that there are different grades of gauge blocks available, some for shop use, some for reference. So that's important to know as well as you're selecting gauge blocks.
Are gauge blocks sold like gauge pins where you buy over and under or nominal, or are they kind of just all supposed to be nominal?
They're all supposed to be nominal.
Okay.
But again, it's always good to have it sent out just to make sure.
Yep.
And the main difference between those and the gauge pins is just you can buy them individually or you can buy them in different size sets.
Yep, got it. Awesome. These ceramics are really cool. One last tip and trick, calipers. I use them every day, they're my go-to. Try to, you can measure between the anvils, that's great. I really don't use these top two parts for measuring ID holes, not a good idea. We can use the
depth bar.
The depth bar,
yep.
Which Drew will show in a second. My little trick, which I don't know why nobody seems to know, you've got a precision hardened ground surface between here and here. So if I want to measure the distance, by setting the inside part there, it keeps the caliper square to the part, which is going to give me a better measurement, and then I can use the roller here, the knurled part, to roll in, and you're going to get a way better measurement than with the depth bar. Obviously, it's much bigger though.
Absolutely. Not all calipers have the depth bar, but the ones that do, as you're using that, you'll want to make sure that the depth bar is straight, right? Make sure that there's no waviness to it. Make sure that it's not bent.
Okay.
Misuse on that, obviously. Now, as you go to use the depth bar, I'm going to set this up here so you see the machine surface that John was just mentioning is sitting on the edge of the part. And
Got
I
it.
can move that down. Now, when you use this, you want to try to keep the caliper as perpendicular, the face that I'm sitting on as perpendicular to the surface as possible. Sometimes you may need to rock to try to make sure that you're finding if there's a concave surface or something below to try to find that. But just be careful on that. Again, you don't want to cause your depth bar itself to get bent.
Right.
You don't want to affect your measurement certainly because you're a little bit.
Yeah, right.
Right? This is a shorter distance, and if you're off a little bit.
Exactly. It's almost like Cosign Air.
Exactly. We should make a video about that.
What's funny, because I don't really like using a depth mic. I think probably because I only have a vernier. I'll just be honest with you. I don't have a digital depth mic, so I end up using the stick a lot, and it's not a good way to measure things, in my opinion.
It's going to depend a lot on your tolerance.
Yeah. Right.
Always keep that 10-to-1 rule.
Awesome. Tell me about that.
Well, the 10-to-1 rule is basically the gauge that you're measuring.
The gauge that I'm measuring.
The accuracy of the gauge you're using for the measurement.
So if I have a print,
10 times more accurate than the tolerance of what you're measuring. That's the 10-to-1 rule.
So if I need to hold 5 thousandths, I need a half a thousandth indicator.
Yes.
So because half a thousandth would be 10 times under the tolerance of 5 thousandths.
Correct.
Interesting.
Correct.
Okay. Not necessarily an end-all be-all, but a good rule.
Yes.
Does anybody know why there's always a notch on the end of a depth bar? Kind of curious.
So on our indicators, whether it's a dial indicator, digital indicator, or test indicator, the contact points are all interchangeable, right?
Yep. Okay.
And so what that can also mean, though, is that the contact point itself is not secure. And so that can affect the measurement, obviously, because you're having a contact point that's not secure to your gauge itself. So another good rule of thumb is to always make sure that your contact point, whatever it is, or whether you're using an extension rod or a contact tip, just a different probe, always make sure of that. Now, you notice also as you pick that up, a couple of our dial test or our test indicator probes have different contact points.
Yeah, so that's just steel, and this has got the
This is the ruby one on that. Again, it's not that one is more accurate than the other, but the ruby is going to wear a lot less. That's why you see it on things such as this. Sometimes you'll see them on roundness style eye and CMM style eye as well. Yeah, like our Renishaw on the Haas has a ruby, but that's getting used every day. For me, I can't imagine I'm probably going to wear out. Well, maybe, I don't know. I mean, you see test fixtures that parts get slidden out multiple times every hour. I can see how over months or years that wear. I mean, stuff, it's again, make no assumptions. Stuff wears, gauge blocks wear, tips wear, metal on metal, period. Absolutely. Another good tip I learned
Never thought about it. Don't store digital, or don't store calipers or micrometers with the faces touching each other, you know, and it's funny because all of I love the Mitutoyo mics, they seem to be the go-to. I always just close them and put them down. Not the end of the world, but it's not a bad idea to just open them up just a hair, and the same with calipers.
Exactly, don't leave it stored.
Micrometers.
Like go ahead and just pull it back, even just a small amount to where you can see some light going through. And then on the micrometers, we have a little locking mechanism here. You can go ahead and just turn that locking mechanism, and it's good for storage that way. That way, because those two faces are precision ground together, and over time, if you keep those stored with them closed, they can start to warp or deform or have a hard time getting back apart. So always store those with a little bit of a gap in between them.
I'm going to ask you a really beginner question. You might get mad at me.
I hope I can answer.
You might get mad at me. So I've noticed this before as well. There's a locking cam here that tightens up the spindle or the thimble. When I'm measuring a part and I can't read it and I kind of want to lock it in, can I start to like snug this down so it doesn't move when I pull it off?
To give it a little more resistance. Ideally, it's not designed to be as a measurement tool. It's designed to be an all on or all off type of deal.
Got it. Okay, good to know. Don't do that. Some of the fun stuff today, folks, has been seeing what other products are out there, because again, when you don't work in a big factory or a big machine shop, you don't always know. Like for instance, I didn't know about these Noga bases with the adjustable base until like a year ago. Where were they? Another really cool thing that's probably not that expensive. You guys have seen it. These, no matter how you're holding these precision measuring tools, human interaction will cause them to bump and bounce around. Look at this. Are you kidding me? How cool is that? Like, it's so cool.
Absolutely. Absolutely.
It's the little things.
And there's different lifting mechanisms. This is one of about 3 that we have. You can actually have this lifting cable that we have here. You can also get an attachment here, a little lever that you can insert. Where you push down on a bar, raise it, you can get a different cap to where you can pull the indicator up or down. Or the simplest way is a little plastic add-on that goes onto the shaft of the indicator. You can just use to raise and lower. Just a little handle on that.
But think like you could put an Arduino on that, and they've got this wireless add-on that dumps the values into Excel, so you could build like your own poor man's statistical process control machine that loads a part in, dumps the plunger down, dumps the data into Excel, and moves on. Like that, how cool would that be?
A little USB processor. Yeah, absolutely. And you know, one thing, this kind of seems like a common sense thing, but it's always good to mention, and I like the way you worded it yesterday when you said with all your measurements, don't be heavy-handed. Right, obviously. So as you're taking your measurements, you don't have to try to He-Man clamp something in. That's not going to help your numbers. That also especially holds true with, let's say, a height gauge. Right? If you're too heavy-handed on your height gauge, as you're lowering the stylus down onto the part, if you're not going slowly, paying attention to what you're doing, it can actually start to race the base of the height gauge off of the surface.
It's funny, this one is pretty nice and heavy and tall, but we use a lot of the little 6 and 12 inch guys, and it doesn't take a ton to roll it over, or like when we're measuring a tool or a part that's cantilevered at all, you can start, I mean, you're trying to measure thousandths or better. It doesn't take a lot to
And sometimes it can be a little deceiving, because when you feel how heavy duty, there's an example. When you feel how heavy duty the height gauge is, or the casting on the tools, sometimes it can be a little deceiving. You think, wow, this is so rugged, and while it is still a precision measuring instrument. So it has to be treated with respect accordingly.
The last one, this may be the coolest one yet. I'd never thought of this until the Richard King scraping class. Gravity. It is real. Want to see something crazy? This is that parallel that I made at the Richard King scraping class. We have an indicator held securely with a Noga base. There's nothing else involved here than gravity. Watch. How much is it moving?
It's quite a bit.
This is what we saw. Now, there's nothing else factoring in here other than the effect of gravity sagging down on this whole linkage system. And when I first saw this, I thought, that's crazy, and then it hit me. For years, I have done things like swept in boring bar holders on a lathe, doing this with this thing held out, frankly, even worse than this. And I had never once thought that when I'm at the upside down position, gravity is pulling that indicator down. Holy cow.
That's pretty wild.
So with that, folks, hope you enjoyed, hope you learned something. I want to thank Mitutoyo for coming out, bringing some pretty cool stuff, and hopefully learning. If you guys want to see more, let me know. Like, this is this stuff is so fascinating to me, and sometimes it's what you don't know. You know, my first time I ever realized how big a deal metrology was when I toured Tom Lipton's shop in Berkeley. And Tom's channel, there's a guy, Rob Renzetti, who has done some amazing videos as well on metrology stuff. It is really, really cool. Thank you, folks. Hope you enjoyed. Take care. See you soon.